So why is 2/5 times 4/5 equal to 8/25? So if you look at this visual model here, you can see it's a 5x5 grid, and out of these 5 squares here, 2 out of the 5 are shaded in. So 2 out of 5 are shaded in this way, and if you look here, 5 across, 4 out of 5 are shaded in over here. So this right here is a model for 2/5 times 4/5, which is what I have here, 2/5 times 4/5. And now how do we get the 8/25? The 8/25 is simply how many of these little squares are shaded in with respect to the whole grid. So as I mentioned earlier, this is a 5x5 grid. So that means I have 5, 10, 15, 20, 25 total squares. And out of those 25, I have 1, 2, 3, 4, 5, 6, 7, 8 squares shaded. So there are 8 out of 25 shaded in, which is pretty much what the solution represents here, 8/25. And you can clearly see that when you're multiplying fractions based on this here, all you have to do to get the 8 is multiply your numerators together, and to get 25, you multiply your denominators together. But if you were to multiply across in every case, you might end up with a fraction that needs to be simplified. And if you need to simplify big numbers, it might be a longer process. So let me show you another way you can do it to keep it simpler. What I recommend is to take your 7/8 and your 4/5 and do the prime factorization for each of those numbers. So here's a prime factor tree for 8. I know 8 is 2 times 4, and 4 I could break it up to 2 times 2. So 8 is the same as 2 times 2 times 2. That's what we call prime factorization, because the numbers that are left here are all prime numbers, and when you multiply them together, you get back 8. So you can see here, 7 is prime. I left that alone. And the 8, I broke it down to 2 times 2 times 2. The 4, prime factorization is 2 times 2, and then 5 is just 5 because it's prime. And as I mentioned earlier, that to get your final answer, you just multiply across. So you can see I did that here. My numerators are 7 and 2 times 2, so I multiply these all together in one numerator, and all these are going to be multiplied in the denominator. But since I did the prime factorization of all these numbers, what you can see is the common factors. And the common factors is what we need to eliminate in order to simplify it. So I can see here, this is a pair of common factors. These are a common pair of 2's. And here's another pair of common factors. And you can see I have a 7 left and a 2 and a 5. So there's no more common factors left between the numerator and denominator. So once you get to that point, just write down what's left. We have a 7 up top, so I'll write that down for my numerator. My denominator, I have a 2 times 5. So if you do have more than one number, just multiply them together, and then you write your final answer. In this case, it's 10. So 7/10 is my final answer. So if you look up here, if I multiply across, this is the correct answer, 28/40. But most likely you're going to be asked to simplify your answers. So when you simplify 28/40, it actually comes out to be 7/10. So I could have multiplied it like I did here and simplify from this point. But like I said, the numbers get bigger, which means you might have a little more trouble if the numbers are bigger to figure out what the common factors are. So while the numbers are smaller, by breaking them apart, you're able to identify the common factors, eliminate them, and then multiply what's left to get your final answer. So it might save you some time by doing that. And then here's another example, 1/5 times 1/10. You can see here, the 10 is the only number that's not a prime number. By breaking it apart, that's 2 times 5. So my numerators, I multiply together. My denominators, I multiply all of those together. And now look, there's no common factors between my numerator and denominator, which means I could just multiply everything and I get 1 over 50. So 1/50 is the final answer. So again, looking back, you can see clearly I would have noticed that between the 5 and the 10, they don't have anything in common, no common factors with the top. So I could have just simply multiplied across. 1 times 1 is 1, and then 5 times 10 is 50. Here's our next example, 1/2 times 2/3. Notice that in this one, these are all prime right here, except for the 1. By definition, prime is any number that's 2 or more. So the 1 is going to stay the same. 2 is prime. This 2 is prime, and this is prime, right? To get your answer, multiply these together and these together. And actually, we do have common factors, the 2's. So after you eliminate the 2's, you can see that the final answer is what's left, and I get 1/3. And now here's an example where you have 3 fractions multiplied together, but the goal is still going to be the same thing. I'm going to do the prime factorization of anything that I can, which in this case, the only one that's not prime is my 4, so I only have to rewrite that one. So you can see here, I rewrote the 4 as 2 times 2. And now, to multiply my fractions, I just got to multiply all these together and all these together. So that's going to give me 3 times 3 times 1 for my numerator, and 2 times 2 times 5 times 2 for my denominator. And after looking at this, I can see there's no common factors between the denominator and my numerator. Therefore, I can just multiply everything together to get my final answer. So you can see here, 3 times 3 times 1 is 9. 2 times 2 is 4. 4 times 5 is 20. And then 20 times 2 is 40. So just want to point out as a reminder that by eliminating the common factors ahead of time, you will know that your final answer will already be simplified. All right, here's my next example, 3/8 times 4/7 times 1/6. So whatever is not a prime number, I'm going to do the prime factorization for each of those. So in this case, I have to do the prime factorization for the 8, the 4, and the 6. So you can see here, the 8 became 2 times 2 times 2. The 4 is just 2 times 2, and then 6 is 2 times 3. Again, this is prime factorization because these are all prime numbers, and when you multiply them together, you get back the original number. And now, I just got to take all my numbers that are in the numerator, multiply those together. So 3 times 2 times 2 times 1. Then my denominator is going to be 2 times 2 times 2 times 7 times 2 times 3. And I look for common factors between the top and the bottom in order to simplify. So I have a pair of 3's here, so I'll eliminate that. I have a pair of 2's here, eliminate that. Another pair of 2's, and that's it. I'm left with a 1 up top. And in the denominator, I have a 2, 7, and a 2. So when you multiply 2 times 7 is 14. And then 14 times 2 is going to give me 28. So this one is 1 over 28. And then here's my last example, 3/5 times 3/4 times 2/3. So I can see here that the only number that's not prime is the 4, so I have to just rewrite that one. So you can see from this step to the next step, I only rewrote the 4 as 2 times 2. Everything else stayed the same because these are all prime numbers. And then you can see in my next step, to multiply fractions, all these in the numerator get multiplied together. All the numbers in the denominator get multiplied together. But before I multiply them together, I'm going to eliminate the common factors because by definition, that's what it is to write a fraction in lowest terms, or in other words, to simplify them. So I look for common factors. I have a pair of 3's in common here. Got a pair of 2's in common. And whatever's left is my final answer. So basically, I have a 3 in the numerator. And in the denominator is 5 times 2 is left, which is equal to 10. And that's the final answer, 3/10.